Hey everybody, welcome back to Understanding VXLAN using BGP EVPN. This is going to be video 4. Last thing we went over on the spine 1 is the address family L2 VPN EVPN. So now we're going to go over the command under that, which is, move this over here, it's going to be the neighbor VTEPs send community both. So what is neighbor VTEPs send community both? Well, in BGP, a community is like a post-it note stuck to a routing instruction. It doesn't change the route itself. It gives the receiving router extra information about how to handle that route. Send community. This tells the spine to include these post-it notes when it talks to the neighbors in the VTEP group. The both command. This refers to two types of notes, standard and extended. So let me show you what that looks like. Just gonna go in here. And I'm just gonna question mark. So here you have the extended, you have the standard, and you have both. In this case, we put both. We'll go over the extended and standard in a little bit. Okay. In a VXLAN EVPN network, the extended community is mandatory. It carries two critical pieces of information called the route target and the route distinguisher, which we'll go in more detail later on. When VTEP 1 tells the spine about Ubuntu Desktop 1, it attaches a route target. Like, let's say the route target would look something like 6500, which is the AS of BGP, colon 10010, which in our case we will attach to VLAN 10. This tag tells other switches this information belongs to VNI 10010. What's the spine's role? If the spine didn't have the send community both command, it would receive that post-it note from VTEP 1, rip it off, and throw it away before passing the instruction to VTEP 2. And the consequence would be, without that tag, VTEP 2 would receive the instruction but have no idea which virtual network it belongs to. It would be like getting a letter with no name on the envelope. So remember what's happening here. You have the underlay, which is OSPF. So OSPF is configured on, will be configured on all these interfaces and all of these interfaces. This is how these devices reach everybody else. It's going to be through the underlay of OSPF. So what it's saying here is when Ubuntu comes up to VTEP 1, VTEP 1 then passes it to Spine 1. Spine 1 will then pass it to VTEP 2, but because it is not configured with the community, it won't know where it came from or what to do with it, right? So just remember that the underlay is OSPF and the overlay is a tunnel. So if VTEP 1 wants to get to VTEP 2, and let's just pretend that this is a regular network, this is not VXLAN or anything like that, right? How would VTEP 1 be able to reach VTEP 4? Well, it would come up here, go to spine 1 and hit VTEP 4, right? But let's say that it's not configured that way. Let's just say that VTEP 1 goes to spine 1, spine 2, spine 3, and then down to VTEP 4. Well, the overlay would still be OSPF. OSPF would reach spine 1, spine 2, spine 3, and then VTEP 4. Now, the overlay would be a tunnel, right? So you would have a tunnel from VTEP 1 and it would see the next hop as VTEP 4. It doesn't see the next hop as spine 1. It doesn't see any of this. As a tunnel, it would only see the next hop as VTEP 4. So that's what I'm trying to explain here is the underlay versus the overlay. The overlay here is going to be the BGP using EVPN, using VXLAN. Hope that makes sense. And if it doesn't, when we start configuring VTEP1 and going through how everything works, it should. So talking about the community again. In BGP, a community is a group of destinations that share some common property. Think of it as a tag or a metadata label that you stick onto a routing instruction. Instead of just saying go to this IP, the community says go to this IP, and by the way, this route belongs to tenant A or VRF-A, whatever the name of the VRF would be. So let's go over the standard versus the extended. Standard communities. These are simple 32-bit values, often used to control how traffic flows. Extended communities. These are larger 64-bit values that are required for VXLAN. These carry the magic numbers that make the overlay work. Under the extended, you have the route target, or RT. You'll see that in the show outputs. The most common one you'll see is a route target. It tells a VTEP which virtual network or VNI to put the route into. Then you also have the route distinguisher, which you'll see as RD. Helps keep identical IP addresses, like two different customers using 10.1.1.1, and it helps to keep it separate in the BGP table. Let me scroll back up here. Okay. So will it always be the same? No. The community values change based on what you're trying to do. The VTEP group, the instructions, when the spine sends an update to the VTEP group, it includes whatever label it has received from the other VTEPs. So for VLAN 10, the community label might be 6500:10010. For VLAN 20, the community label might be 6500:10020. The community value is what allows VTEP1 to send info about Ubuntu Desktop 1, which is on VLAN 10, and ensure that VTEP2 doesn't accidentally put that info into VLAN 20, right? So again, VTEP1 VLAN 10 is going to be associated to VNI 10010, and VTEP2 is going to have the same information for VLAN 10. The VNI is going to be 10010. So whatever VLAN you assign here, let's say you assign this 1000 or whatnot, and you assign that VLAN the VNI of 10010, then this guy will be able to talk to this guy because they're in the same VNI. Doesn't matter what VLAN they're in, what matters is a VNI. The next command is the neighbor VTEP's route reflector client. So again, remember, this is going to be assigned to everyone in this group, which is these four here. So what is neighbor VTEP's route reflector client? This command is a secret sauce that makes the spine and leaf architecture work without having to connect every single VTEP directly to every other VTEP. So remember, in BGP, you can have a full mesh unless you use route reflector clients. To understand this, you have to look at the fundamental rule of IBGP, or internal BGP. The rule is a router is forbidden from telling an IBGP neighbor about any route it learned from another IBGP neighbor. This rule is there to prevent instruction loops, or loops, where instructions spin in a circle forever. However, in this topology, the VTEPs are only connected to the spines. They're not connected to each other. So if you don't have the command here, it would go like this. VTEP1 tells spine 1 about a PC. Let's say Ubuntu Desktop 1. It tells spine 1 about it. Spine 1 hears the news, but because of the hard rule, the IBGP rule, it stays silent and won't tell VTEP2 or VTEP3. The result? The network breaks because the other switches never get the instructions. By adding this command on the spine, you're designating the spine as the teacher or route reflector and the VTEPs as the students or clients. So imagine a room full of students and everybody's talking. Everybody wants to give their opinion or whatnot. Well, nobody's going to hear anybody, right? And everything's lost. But if you have one student tell the teacher something, then the teacher can then tell everyone else about what that one student said. That's basically how route reflector works. So again, instead of having to make 100 separate connections between 100 VTEPs, which would be a full mesh, every VTEP just talks to the spine, and the spine reflects the news to everyone else. The spine is smart when it reflects a route. It adds a special tag called an originator ID. If the route ever comes back to the spine, it sees its own tag and says, I already know this, and drops it. So the last command here would be the activate. So here we're activating the neighbor for that specific language, right? Think of it as open for business sign for that specific language, this specific language, right? L2VPN, EVPN. So if you don't have that command in there, the spine might have the neighbor's IP address of 11.11.11.11 in its list, but it won't send any EVPN instruction or MAC addresses to it. But with it, the spine says, okay, I'm officially allowed to exchange EVPN data with VTEP1. Alright, in this video we covered all the commands that are needed for BGP EVPN. In the next video we'll start with VTEP1. Hope to see you there.